Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. My name is Abbas and doing a PhD from University of Peshawar. My today topic my today discussion topic is the synthesis of carboxylic acid through the oxidation of ethyl methyl ketone by using the K2Cr2O7 potassium dichromate oxidizing agent in the presence of H2SO4. In the first step, the ethyl methyl ketone is uh, oxidized to butadiene. Over here, the gain of oxygen the gain of oxygen and loss of hydrogen occurs. In the second step, the reaction of K2CrO4 with butadiene it gives two acetate ions. When the acetate ions gains the hydrogen ions from H2SO4, it form it forms acetic acid. In this reaction, the of oxidation of methyl group to carbonyl C double bond O group takes place. Oxidation of methyl group to carbonyl group takes place. Ethyl methyl ketone or butanol plus K2Cr2O7 in the presence of H2SO4, it forms CH3. It forms CH3 C double bond OH plus CH3 C double bond OH. 1 mole of ethyl methyl ketone, when oxidized, it always gives the 2 moles of acetic acid in final product. It means 1 mole of ethyl methyl ketone when oxidized, it gives 2 mole of acetic acid molecule. Mechanism in the mechanism, ethyl methyl ketone in the presence of K2Cr2O7 oxidizing potassium dichromate oxidizing agent, and also in the presence of H2SO4, it gives two molecules of acetic acid. In step 1, in the first step, addition of oxygen at alpha carbon takes place. CH3 C double bond O, CH, here H or CH3 plus K O negative CR C double bond O, C double bond O, O CR C double bond O, C double bond O negative, K positive. Here the hydride ion shifting takes place. Here the hydride ion shifting from alpha carbon to this oxygen oxygen to this oxygen, and the pi bond between the oxygen and bromine and oxygen and chromium shift on chromium, absorbed by the chromium, while the C oxygen, uh, in this one double bond between oxygen and chromium shift toward the oxygen, and this negative oxygen attack on this positive center, this positive carbon, and form uh, and form oxygen carbon bond and oxygen Cr bond. Here in this state, here Cr+6, while when in this one, here the plus 4. The oxidation state of Cr becomes less, becomes Cr+4. It means a reduction reduction of the chromium ion takes place. This is the addition product. The one of Cr+6 changed into Cr+4 by absorption of 2 electrons. It means reduction takes place. In step 2, the oxidation of reactant means gain of oxygen takes place. Here CH3 C double bond O CH CH3O CrO OH CO CrO Cr double bond O double bond O Cr double bond O Cr double bond O CrO K positive. Here hydride ion shifting takes place. Here the hydride ion lasts, while the bond between the chromium and oxygen shifting towards the oxygen, which is sheared between the carbon and oxygen, and becomes the carbon oxygen bond becomes double, which is called carbonyl, which becomes a carbonyl group, while the negative charge of the oxygen shear to the chromium. Here the two lone pair also shared, and this pair, this bond which is between the oxygen and chromium shift on oxygen, and this oxygen shear this pair to the Cr, while the another pair, while the second pi, while the one of the 2 pi electron shift on one oxygen, and here over here the hydride ion, from this hydride ion from this portion, and H ion from hydrogen ion from this portion react with each other, combine with each other, and form H positive plus H negative, form H2 gas, which is lost to the surrounding. And CH3 C double bond O C double bond O CH3 C double bond O CH3 plus O plus O C double bond O O double bond Cr यहाँ either here O C double bond Cr, this bond becomes departure, and this bond also becomes departure. Cr double bond O, Cr double bond O, or here CrO2, another oxidizing agent, is obtained, and here O double bond Cr, O Cr double bond O, Cr double bond O over here is formed, and CO double bond Cr, single bond O negative, double bond O, and O negative K positive. This compound K2CrO4 also obtained in this process, in this step. Step 3 over here, dicarbonyl compound react with the K2CrO4 oxidizing agent, which have this one structure, the pi electrons of the carbon oxygen Cr double bond shift or attack on the shift towards oxygen, due to which the oxygen attack on the one of the carbonyl group, and the carbon bond of the two carbonyl group becomes shift on one of the carbonyl group, and attack on the this oxygen of the oxidizing agent, and the pi electron of the oxygen chromium double bond shift are gained by the Cr positive carbon. The pi electron of the oxygen chromium double bond shift are absorbed by Cr, due to which over here the oxidation state of the chromium is a +6, while when this is the this bond becomes ruptured, CH3 C double bond O, this bond attached to this oxygen, this carbon attached to this oxygen Cr to oxygen to Cr, O C O O C double bond O CH3, and Cr O negative K positive, O negative K positive. Over here +4 oxidation state of the chromium is achieved. Over here in another progress under process step, over here the bond between the oxygen and chromium becomes a shift on oxygen, which forms the acetate ion, and also the here potassium, so potassium acetate salt is obtained, while the another bond between the acetate ion and Cr, the bond between the oxygen and Cr of the acetate ion and Cr bond, the bond between the oxygen and Cr shift on oxygen, and they form another type of acetate ion, and also the potassium ion is attached, and they form another molecule of the acetate ion. Similarly, 1 and 2, as there are two acetate ion is attached to this addition product, hence these gives the two types of sodium potassium acetate plus Cr. Over here, this electron shared to the oxygen chromium bond, and this negative oxygen shear to the oxygen. This pair of electrons sheared to the oxygen chromium bond. Similarly, this oxygen and chromium bond becomes ruptured, and this oxygen and chromium bond becomes ruptured. Similarly, they form double Cr double bond O, Cr double bond O, which gives this type of compounds Cr double bond O, Cr double bond O. Step 4, the H2SO4, the H2SO4 gives the hydrogen ions to the potassium acetate ion. So over here, the protons given to this one, which is absorbed by the acetate ion, and gives 2 carboxylic acid. And HSO4 ion is one of the molecule gives one HSO4, and two molecules gives 2 H2SO4. Hence, 2KH, 2 potassium bisulfate ion is produced. This was the method of synthesis of carboxylic acid from the ethyl methyl ketone by using the potassium dichromate oxidizing agent. Okay, guys, if you enjoy and gained some knowledge from my video, please subscribe it. Thanks a lot. Thanks. May Allah succeed you all. Ameen summa ameen.